Hello and welcome to my general problems mechanics walkthrough. Today we're going to be looking at a question involving an accelerating engine part. Let's get into the question. An engine component in a Formula One racing car can experience extreme mechanical loadings. If one of the pistons moves up and down in its cylinder through a total distance of 8 centimeters, estimate the maximum acceleration it experiences when the engine is operating at 12,000 revolutions per minute. So first thing we can do is draw a little diagram of our piston, and we know that it moves up and down over a total distance of 8 centimeters. If we are to plot this on a space-time graph, a distance-time graph, we get a sinusoidal path with an amplitude of 4 centimeters because it's half of the total distance moved. This can be written as x equals 0.04 sine omega t minus phi, but because we're only bothered about the acceleration, we don't need to know what phi is, and we can just assume that phi is 0. If we want to find the velocity, we can take the time derivative, which gives us 0.04 omega cos omega t. And we can do this again to find our equation for the acceleration, which is minus 0.04 omega squared sine omega t. But we know that the maximum number sine can be is 1, so our A max is 0.04 omega squared. But we need to find out what omega is. So if we look at the frequency, we have 12,000 revolutions every 60 seconds. This is the same as 2,000 revolutions every second, and the frequency, the relationship between angular frequency and regular frequency is omega equals 2 pi f, and if we put this into that equation, we get omega equals 400 pi. So we can now sub that into our equation below. So A max equals 0.04 times by 4,000 pi squared, and we get our final answer of 6.32 times 10 to the 6 meters per second squared. Thank you very much for watching this video. If you have any questions or didn't understand any steps, please let me know down in the comments below. Thank you very much.